Retard. What reason? Because I'm calling.
Alright, today
That's way better.
we are going to take a look at stuff that should just be a review from Algebra 1. Okay, today should be, hopefully it's an easy, straightforward day. Okay, we're not doing any brand new stuff. This is all a review from Algebra 1. The reason we're doing this, okay, is because we are going to start talking about parallel and perpendicular lines. Okay, so we have to review slope and writing the equation of a line today. Tomorrow, well, Monday then, we will take a look at equations of parallel and perpendicular lines. So the first thing that we need to review is slope. Okay, so given 2 points, my slope formula is right up here.
Little too much side conversation.
Okay, my slope formula is up here in the top. y2 minus y1 over x2 minus x1. So I'm just taking the difference in my y coordinates over the difference in my x coordinates. So let's jump right into an example of that. Okay, I want to find the slopes of both of these lines over here in my figure. So first, it says find the slope of line P. So line P is right here, and they give me 2 coordinate points on that line. Okay, so I'm going to take my first coordinate point, and I'm going to label that x1, y1. Okay, we're labeling the same way we did when we did distance formula and midpoint formula. Okay, I'm just going to label my points x1, y1, and x2, y2. So that my formula to find the slope is y2 minus y1 over x2 minus x1. So y2 is negative 2. y1 is positive 2. So I'll have negative 2 minus positive 2 over x2 minus x1. So x2 is negative 2, and x1 is 1. So negative 2 minus 1. So negative 2 minus 2 is negative 4, right, over negative 2 minus 1. So that'd be negative 3. Now, I got a negative in both the numerator and denominator. Right? So if I've got a negative over a negative, those just cancel out, and this would be a positive. Right? So a negative over a negative is just a positive. So what we just found is the slope of this line. Okay? Graphically, okay, if you remember, the slope is rise over run. So what that means, okay, is if I choose any point on this line, okay, it doesn't matter what point I choose, okay, but we can choose this point. My rise is the change in the y coordinates, right, because I did y2 minus y1. So rise is how far up or down I'm going. So if I start at this point, I'm going to go up 1, 2, 3, 4, and then my run is how far to the right I go. So I'm going to go over 1, 2, 3. So the slope of my line, we say, is up 4 over 3. That's how I state how steep this line is. Okay, it has a slope of 4 over 3. Okay. You okay with that one? Okay, so you guys go ahead and try the same thing for line Q then. Okay? Calculate the slope. y2 minus y1 over x2 minus x1. Yeah, I believe that's what it's going to be. So I think we should get -2/5 for the slope. Okay, I think we end up with 2 over -5. So if just one of the numbers is negative, we can pull that negative out in front and just say that the entire fraction is negative. And so -2/5. So graphically, what that means is if I start at any point, okay, the negative tells me I'm going to go down. Okay, negative tells me I'm going to go down. So if I'm looking at line Q here, I start at some point, I'm going to go down 2 and then right 5. Okay, that's how we tell the steepness of this line. Okay. So that's one way. I always like to just say up or down and then right, but technically that is true. Okay, I mean if we say 2 over -5, this would be up 2 and then left 5. For kids to remember, I've kind of found it's easier to just say up or down and then always right. But you are correct. So Evan said that if we look at this form, the 2 over -5, well, since my numerator is positive here, that means that's the same as saying, well, we could go up 2. And then the negative run means go left 5. Okay? And if you remember that, that's perfectly fine. Okay? That's absolutely perfectly fine. The way that I've always taught slope, okay, is just if it's negative, you go down. If it's positive, you go up, and then you always go to the right. But if you remember it as if it's positive, if the numerator is positive, you go up. If it's negative, you go down. And then if the denominator is positive, you go right. If it's negative, you go left. That's perfectly fine. All right? So questions on calculating slope so far? Okay, so let's just practice a couple more of those then. Okay, so in these exercises down here, we don't have a picture. Okay, we're just given 2 coordinate points. See what? Maybe you saw the same note sheet in this class last year. Okay, so yeah, let's just take a couple of minutes here, and you guys find the slopes up here. And remember our slope formula: y2 minus y1 over x2 minus x1. I should also mention, we always want to reduce our final answer as far as possible, right? So we'll get a fraction, and we want to make sure that it's in lowest terms.
You're lying. I know you're lying. You're just saying that. You serious?
Yeah.
I can't talk to you. No.
I used to.
You need to make so it's -5 minus.
So that would be the same as -5 plus.
Oh,
-5 plus 3.
There.
That long. What's up, guys? 15 years ago.
What do I do? What's up? I got.
Yeah, so now to reduce it, you can actually just do that division. So what's 8 divided by -2?
That's how they always start.
Negative. Because one of the numbers.
A little number.
Since we're talking about a slope, we usually want to do
Put it over like 1.
Exactly. Yeah. -4 over 1.
Yeah, you're down here. I'm not down there yet.
Oh yeah.
8 minus 0 plus 2.
B equals 2. As you're doing 1.2, that's going to share 0. First one would be y equals 2 base minus a. I don't know what to do for 11 Sweet.
Yeah, so y coordinates always go up top. So yeah, I guess I should have labeled the points. So in coordinate points, x is first. So I always put the y's on the numerator. So y2 minus y1 on top, and x2 minus x1.
What are we talking about? It actually happened.
Just mix up the numbers there. Yeah, we label x1, y1, x2, y2. Then up here, y2 minus y1. Maybe negative 5 minus negative 3. Over 3 minus negative 2.
You 5 over 2.
No, that's a 7.
That looks a lot better too.
That is a 7.
Yeah, I know.
7 is like this. He doesn't say that's weird.
What kind of 2s are you?
What kind of 7s are you drawing?
I'm drawing a 7 and crossing it. That's my 7.
Yeah, well, far away. Come back here. Yeah. Come back here.
What looks like a 7?
My standpoint looks like 2.
Looks like a 7.
What?
He's saying that this looks like a 2.
What?
It looks like a 7.
That looks exactly like a 7.
Where? That's a 7.
What's going to say?
Bubbles. Eyes blow up. I'll show the part.
Oh.
His first year teaching was my junior year, and I had chemistry. My junior year would have been 2006, 7. I'll be 30 in a couple months.
Hold on, I'm younger than that. Hold on.
Failure?
Can you help me say?
Do you remember anything? You know how to calculate?
How long have you been?
I give it seconds. No, this is my first time doing this, so I need to try to go right. Don't even try to pull that. You're mean to me all the time.
All right, so our answers for 1, 2, 3, and 4, okay, are up here on the board. Okay, for 1, I think we get 8 over negative 2, but then we can reduce that to negative 4 over 1. Technically, we could just write that as negative 4, but since we're talking about a slope, I want you guys to write it with a numerator and a denominator. So even if we get a whole number, okay, put it over 1. Okay, write it with a rise and a run, numerator and a denominator. Excuse me. Now for number 2, we ran into subtracting some negatives. So if I label my points x1, y1, x2, y2, and I plug those in, I get negative 5 minus negative 3 over 3 minus negative 2. Okay? We have to be careful with these double negatives here. Okay? So whenever you're plugging in a negative value, it's a good idea to use parentheses to keep your negatives straight. So negative 5 minus negative 3 is the same as negative 5 plus 3. Right? So negative 5 plus 3 is negative 2. Same thing in the denominator. I've got a double negative. So 3 minus negative 2 is the same as 3 plus 2. So that would just be 5. Okay? And we run into that in a couple other places. In the numerator in number 3 and in the denominator in number 4. Okay? But I think negative 5 over 7 should be our answer for 3. And negative 1/2 for our reduced form should be our answer for number 4. Okay? We okay with these? Okay. So now, let's take a look at writing equations of lines. So up at the top, and back up at the top of your paper, there are 2 important forms of lines. Okay? The slope-intercept form and the point-slope form. Okay? Y equals mx plus b, okay, which I think is the one you guys have worked with a lot more. And then our point-slope form of a line. Y minus y1 equals m times x minus x1. So we're gonna use this one, the slope-intercept form here, to start out. So I'm gonna write that over to the side here. Y equals mx plus b. The 2 important pieces here. Okay, m is the slope, right? And b is the y-intercept. So in the next 4 problems down there, okay, it says find the slope, then write an equation of the line in slope-intercept form. So I'm starting with line AB. So AB is this line right here. Now, if I'm given a graph, I don't have to write out the whole slope formula. Right? If I'm given a graph, I can just count the slope on the graph. Okay? I can pick out 2 points that I know for sure. Okay? They give me a couple of points here. So if I use A and B, I'm going to just count. So from A to B, I go up 1, 2, 3, 4, 5, 6, and then over 1, 2. So my rise would be 6, my run would be 2. So my M is 6 over 2. That reduces though. How would that reduce? 3 over 1, right? Okay. Now, then it says I want to write the equation of the line in slope-intercept form. Okay, well the 2 pieces of information I need to write the equation are the slope, which we just found, and the y-intercept. Okay, y-intercept is just wherever the line crosses the y-axis. So again, I can just look at the graph and get that information. So this line crosses the graph at 4, or it crosses the y-axis at 4. So my b value is 4. So my m is 3, my b is 4. So to write the equation of the line, I'm going to say y equals 3 over 1x plus 4. Right? My slope goes here, my y-intercept goes here. So the equation of this line.
Well, what's that?
So to write the equation of a line, right, we're using y equals mx plus b.
So line y.
So I'm writing the equation of this line. So we just found the slope, right? We found the slope was 3 over 1. And the b value is the y-intercept. So that's just wherever the line crosses the y-axis. So it crosses at 4. So then to write the equation of the line, I'm just plugging these two pieces of information in for m and b. So my m is 3 over 1. My b, the y-intercept, is 4. So the equation of this line is y equals the y-axis, yeah. Okay, so we can get the slope from the graph, okay, by just counting the rise and the run between two coordinate points. And then we can get the other piece that I need, the y-intercept, just by looking at the graph again. Okay? We think we can try CD. Alright, I'll take a look here. So CD is this line right here. Right? So find the slope, then find the y-intercept, and put those pieces of information together to write the equation of the line.
All right. You got any room to talk over it? No, exactly. You guys expect us to remember everything? Teachers expect us. Teachers expect us. Our brains aren't even fully developed. Y'all are fully developed and go through college and still can't remember algebra 1.
This is the part that I really struggle with.
Number 7. My step is CD.
I got an A. Did you?
And then so this one, since it's not, it's just split. That means 0.
Yeah, so 4. Yeah, it'd be 4. Right. Yeah.
And then what would I put for the y-intercept because it doesn't cross the y-axis?
Right. This one's kind of a special case.
That's where I had the question because that's where I got lost accidentally crossing.
So yeah, this one gets a little funky. We're gonna look at that one here. So on number 6, okay, I think we should get a slope of -2 or -2 over 1 when we reduce. Okay, counting from C to D, I would go down 4 over 2. So that slope would be -2 over 1. And then my y-intercept, okay, the place where this line crosses the y-axis, is at -2. So putting that information together in my y equals mx plus b, my m is -2 or -2 over 1. My b is also -2 in this case. So my equation would be y equals -2x minus 2. Okay, we okay with those ones? So now, in 7 and 8, something a little bit weird happens. Okay, if I look at number 7, I want line EM. So EM is this line over here. That's a completely vertical line, right? So if I think about the slope, okay, so if I'm looking at the slope between E and M, well, my rise, I would go up 4, but then my run is nothing, right? I'm not going left or right at all. So I get a 0 for my run, a 0 in the denominator of this slope. What does that mean if I get a 0 in the denominator of a slope?
It's 4.
It's a
4 over 1.
No, we got 4 over 0.
Well, fix it.
No, 4 over 0 is correct.
It's just 4. No?
Can I divide by 0? Am I allowed to do that? No, right? I can't divide by 0. So it's not just 4.
4, that's what I said.
Amanda? It's undefined. Okay? Whenever we get a 0 in the denominator, our slope is undefined.
Now, what if I did that in algebra?
That's
Can just be forged?
because we can't divide by 0. So yeah, even like no matter what math you're doing, you can't divide by 0. So if you get that in algebra, you would say there's no solution or it's an undefined solution. Okay. So now the second part then is to write the equation of this line. Okay, well, this line doesn't cross the y-axis, so there's no y-intercept, and we just said the slope is undefined. So writing the equation of this line is going to be a little bit funky. If I have the x-coordinate of each point is the same, right? The x-coordinate here is 4, the x-coordinate here is 4, 4, 4, 4, 4, 4, 4. The x-coordinate at every single point on this line is 4, right? So the way that we write the equation, okay, we just say x equals whatever that x-coordinate is. Okay, in this case, the x-coordinate of every single point on this line is 4. So the way that we write a line like that is x equals whatever the x-coordinate is. That is going to be true whenever we have a completely vertical line. Okay, so I mean, you can make a star here. This is a special case. This is whenever we have a vertical line. Okay, and it's just going to be x equals the x-coordinate of every point on the line. So in this case, every point on that line has an x-coordinate of 4. So the equation of that line is x equals 4. Okay. You okay with that one? Okay, that's a special case. That one's a little bit funky. Okay. So then in number 8, okay, ED, this is our other possible special case. Okay, ED is a completely horizontal line. So if we want to calculate the slope, okay, between E and D, well, my rise, to go from E to D, I'm not going up or down at all. So my rise would be 0. And then my run would be 4. Can I have a 0 in the numerator? Can I do that division?
Here, right?
Yeah, we can. Okay, 0, what's 0 divided by anything? 0. Okay, so this slope, we just say is 0. Okay? Now, we can actually think about writing this in terms of slope-intercept, because this does cross the y-axis. Right? My b value would be right here at -2. So if I want to take this information and plug this into y equals mx plus b, well, my slope is just 0 times x, and then my b is -2. Well, what's 0 times x?
0.
0. Right? 0 times anything is just 0. So 0 times x is still 0.
0 is good there.
So this, I can essentially get rid of, right? This is just 0 minus 2. So we can say y equals -2 is the equation of this line. Right? Again, we can put a little star here, right? This is true of every horizontal line. And whenever my slope is 0, the line will be completely horizontal. And it will always be of the form y equals whatever the y coordinate of every point on this line is. So if I look at any single point on this line, the y coordinate is going to be -2. Okay, so those are the two possible special cases. We have a completely vertical or completely horizontal line. Okay? More often, we'll be looking at ones like 5 and 6, where we can count the rise and the run, and then look at the graph to get where it crosses the y-axis, to get the y-intercept. Okay? Questions on those? Okay, so then the last thing for today, okay, is to write an equation just given some pieces of information, right? Not given a graph. So in numbers 9 and 10, I am given the slope and I'm given the y-intercept, right? M is the slope and B is the y-intercept. So I'm given the information I need here to write my equation in y equals mx plus b form. I can just plug these two values in, right? So my m is 2, my b is -3. So the equation of a line with a slope of 2 and a y-intercept of -3 is y equals 2x minus 3. Okay. Go ahead and do the same thing for number 10 real quick here. Hopefully it takes you about 4 seconds.
How are you doing?
Y equals mx plus b. Where did you get all that extra stuff
What extra stuff?
from? Mx plus.
This is the y equals mx plus b. So then my slope, I'm just told the slope is 2, and I'm told the y-intercept is -3. So the equation of this line, I'm just plugging 2 in for m and -3 in for b. So I'm going to do the same thing over here. Right? If I've got y equals mx plus b, I'm plugging -1/2 in for m, 4 in for b. So number 10 should be y equals -1/2 x plus 4. Okay. Now, in our last two examples, we're given a little bit different information. Okay, I'm given the slope, but then I'm given some random point. Okay, this is not the y-intercept. Okay, if you look back up at the top of your paper, there is a slope-intercept form of a line, and there is a point-slope form of a line. Okay, the point-slope form of a line looks like this. Okay, so we have to look at the information we're given. If I'm given the slope and a y-intercept, I'm going to use slope-intercept form. If I'm given the slope and a point, we're going to use point-slope form. Okay, hopefully that makes sense. If we're given the slope and an intercept, we use slope-intercept. If we're given the slope and a point, we use point-slope.
So we write it down just as 3.
So what I'm going to do, I'm going to use this equation here. Okay? Y minus y1 equals m times x minus x1. And I'm going to plug this information in. So when I'm given a point, just like we did when we found the slope, I'm going to label this as x1, y1. So then I'm just going to plug these two values in for the correct places. 8 will go here, 3 will go here. So I'm going to write this as y minus 3 equals 1/4 times x minus 8. Okay, now I want it to look like this. So now I have to take this equation and solve for y. To do that, I'm going to start by distributing this 1/4 through. So 1/4 times x is just 1/4 x. What's 1/4 times -8? -2. Then my last step would be to add this 3 over. We get y equals 1/4 x. -2 plus 3 would be plus 1. Okay. So in our final example here, what two pieces of information am I given?
You know what?
In this last example, number 12.
No, I'm still on 11.
Oh, okay.
Yeah.
What's up with number 11?
Let's get the X and the X1. Oh,
So-
never mind. I see it. Never mind. I see it. Go ahead. Go ahead.
Are there other questions on 11? Before we move on to 12?
Yeah.
Okay.
Still trying to break it all down. Oh, this should be. Okay, never mind. I think I got it. I might not.
Okay, so on number 12, what two pieces of information am I given? This, I don't know why this says E here. There should be a E there. I'm given the slope and a point. So if I'm given the slope and a point, which of these two equations should I use? Slope-intercept or point-slope? Point-slope. Right, so I'm going to take my y minus y1 equals m times x minus x1. Okay, and we can label our point, right? This would be x1, y1. So I plug this information in now. So my y1 is 5, so y minus 5 equals, my slope is -3 times x. Now this is a -2, right? So this is going to be x minus -2. Okay, so now I'm going to go ahead and rewrite this before I distribute. Okay, x minus -2 is the same as x plus 2. Right? We can just change that double negative to a plus. Now I can distribute this -3 through my parentheses. So -3 times x is -3x. -3 times 2 would be -6. Then my final step to get y by itself would be to add 5 to both sides. So y equals -3x minus 1. Okay. Questions?